So as I mentioned in my email this afternoon, that this is the shortest topic, but that does not mean that it is not as important as the others. In fact, this is probably one of the important concepts and principles in project management that we need to understand because it plays an important role in many aspects of business. And as we will see, that understanding this concept of learning curve will allow us to do most of many of these things that are listed as application areas, starting with manpower planning and scheduling. When you have a project, we talked about project management, it is important that we're able to estimate the manpower hours required because it allows us to schedule our people. Additionally, understanding your manpower need will allow you to generate budgets. You can assign costs to the manpower associated with projects. When it comes to purchasing things, it allows you to negotiate prices because when you negotiate with prices, you need to understand the cost of providing a service or product. And we'll talk about this more in detail in next week when we talk about cost volume analysis, where when we set our price for our product or service, we have to know the variable cost component. And part of the variable cost component is labor. And other cost items, variable cost items are fairly easy to, not easy, I wouldn't say fairly, but more can be directly estimated, unlike labor, which can be affected by this concept of learning curve theory. So another area where the application of learning curve is important is in pricing new products or new services. Again, this ties back into this concept of variable cost, because once you have variable cost, you can tack on margin so that you can have your price. So, learning in terms of the operations strategy, learning curves have strategic implications for when you try to enter a market to rapidly gain market share. And this again will tie to this concept of pricing. As you may have learned in your marketing class, pricing is a way to, well, compete in the market. And you see this in the business strategy game. You set your price, hopefully not too high, because if you price your product or service too high, then especially if you are competing in a very competitive market, then you're pricing yourself out of the market. Yes.
While also kind of paying attention to price sensitivity, right? So based upon the quality of your product, you can charge X amount of dollars to say that this quality of this product is representation of this price, but only a marginal increase year over year.
Right. So in terms of when you say marginal increase, you have to match that against how much you spend in your quality assurance or what was the quality rating. And as I mentioned earlier, learning curves is important in capacity planning. We will see that in one of the examples we will consider tonight. Okay. Now, what is the learning curve theory all about? First, I'm going to say that the learning curve theory is not applicable to machines. It's only applicable to human beings. All right. Second, that the learning curve theory is applicable in tasks that are not repetitive, but tasks that have some complexity in them. Okay? So when we are talking about simple activities, like, for example, collating papers and stapling papers is a very simple task. We really can't apply learning curve theory there because a simple task, you don't expect any learning that will occur as you perform the task repeatedly. Okay? So, for complex tasks, we assume that we human beings are capable of learning from experience. That is, as we do something that is complex, as we perform that complex task more and more, that we learn from each time we perform that task. Okay, in other words, there is learning that is going on. That also, the learning effect is predictable. And I've done some experiments on this, years ago with my undergrad students. I'd bring a box of Lego toys with probably, say, 200 pieces. And then I would ask them to assemble, disassemble, and reassemble the toy X number of times. So they were talking about experimenting or taking a sample so that you can understand the learning effect. And we've observed that there is a predictable pattern of improving the completion time of each succeeding unit. All right. In learning curve theory, and this is an important, not necessarily assumption, but this is proven. This is you can replicate and prove this through sampling. In my case, asking my students to assemble, disassemble, and then assemble again multiple times Lego toy, and for each time that they assembled the toy, they recorded the completion time. So we were able to track the completion time of the first unit, the first toy, the second assembly, the third assembly, and so on and so forth. So this is an important assumption. Percentage of learning is constant. Now, this learning percentage is applied to the second bullet point here that says the percentage improvement in unit completion time, you will observe that on every doubling of repetition. Meaning, you will observe that when you perform, say, the first time you assemble this toy of 200 pieces, and then let's say that the first time it took you like maybe, let's say, 50 minutes, okay? And then the second time, it took you 45 minutes. All right, so here's a doubling of repetition from 1 to 2. And the improvement in unit time from 50 to 45 is what percent? 10%, right? So that is the 5 divided by 50. You've shaved off 5 minutes on the second repetition. So the 10% improvement is actually, when we talk about learning percentage, this is a complement of that. So instead of 10%, you will say here that assuming that this doubling of repetition improvement is observed again on the fourth, because that's a doubling of repetition. So that the 90% learning percentage applies to this situation. Okay, so what is 90% of 45 on the fourth repetition? That, I mean, we can compute that by hand. 45 times 0.9. So you would expect that it will take 40.5 minutes on the fourth. So here we see that the doubling of repetition from 1 to 2, from 2 to 4. And then the next doubling of repetition would be from 4 to 8. And the 8th unit, assuming a 90% learning rate, would take 36.45 minutes. Okay? Now, say, question is, what happens to what if I wanted to compute or determine the third or the fifth, the sixth, the seventh? How do I compute those? Well, fortunately, there is a formula that will allow us to compute the third, the fifth, and the sixth, and the seventh. Let me show you the formula. Here it is. Okay, so this is the only equation that we need to understand in learning curve theory. So here's the equation. It says T sub n would be the nth unit. So if I wanted to compute the third unit, T sub n, 3, applying this formula, it says, what was the completion time of the first unit? 50, okay? And raised to the power b. So times n, which is 3, raised to the power, raised to the power b, and so b is defined as natural log of r, where r is the learning ratio. Okay, in this case, the learning ratio is 0.9 divided by L and the natural log of 2. So that is always ln 2. So we'll say that ln 0.9 divided by the natural log of 2. So that's the equation that is used in computing the intervening units. Okay, so let's compute the third using that equation. Equals 50, and for this, you probably would want to use Excel, or you have a scientific calculator where you have to make sure that the ln 0.9 divided by ln 2 is raised to the power. Okay, but if you are using Excel, let me open a new Excel. And part of today's demonstration also, I'm going to show you how we create a learning curve table, as well as creating the graph. All right, so I'm going to put it here, and this is kind of how I develop those models. For the learning curve, we need only 2 pieces of information, right? T1 and the learning percent. So those are input cells. T1 in this case was 50, and the learning percentage 90%. When I use Excel, I really don't want to see the grid lines because it's much cleaner. So we want to compute n, the nth unit. So in here, I'm going to put 3. Well, let's start with 3. Okay. Again, now, where's my? I don't have the draw option there. We will refer to this equation, okay? So we will say T n equal to 3. Enter, and this is a computed cell. So we will usually use blue. Apply this equation up here using the cell reference addresses. T1 is that, okay, times n. So I'm going to put it in parentheses. So I want to preserve the correct order of operation. N would be this raised to the power, so use the caret, like a greater sign inverted or pointing up. And then I'm gonna put in parentheses the whole ln natural log of, instead of 0.9, I'm going to refer to the learning percentage divided by, oops, I need to close that, divided by the natural log of 2. Okay, and then I need to do one more parentheses. So you see how I translated the learning curve equation into Excel function.
Can you do that one more time?
Okay. Alright, so I'm gonna, what was the answer? Did we didn't complete that, right? But let me add something here. Instead of the n, let's just say, so let me redo this. I'll make it bigger, hopefully. Right, equals T1, which is that, times n, which is this, raised to the power, ln, and then the ratio is this, C7, divided by natural log of 2, close, that's it.
So you typed in.
Yes, you have to.
It's a function, yeah.
It's a function, a natural log function. All right, so that's how we created that. I'm going to delete that. Are we good so far here?
Yes.
Yes? Okay, good. Now, let me alter, this is something that you might want to apply when you're using Excel, that if I say I want to compute the 5th unit, we already know the 4th unit, right? Because we computed that by hand. But what about the 5th unit? And the 5th unit is, well, is somewhere there. We want to compute the 5th unit. Well, I'll just change the value of cell C10 and it computes that to be 39.15 minutes. But look, it still says 3. I want that to say n equal to 5. All right, how do I do that? Now, here, I simply typed in the Tn equal to 3. If I want to make this dynamic, meaning it will change certain things within that cell or the result of the cell, to say instead of 3, to say 5, what we can do is we can use a function called concatenate, right? Fused together. We will concatenate a group of characters and variable. What is the variable there? The variable will be cell C10. We want that to change. But the characters that we want to retain are the n equal to, and then parentheses, or if we want in parentheses. So let me rewrite, let me copy that so we can see what I eventually want to accomplish. Okay, equals concatenate. And so in this case, T, N, and equal are characters. So if we want to embed characters, we would want to use a double quote, T, N, then equal to, and I'm just doing some formatting here so that the N equal and 3 will have some space in between. And I would want to say 3 after the equal sign. But 3 is a variable. So I will put a comma there to tell Excel that the next item will be a variable. And I would pick C10. There you go. And if I change this to 7 or to 6,
Okay.
to 7, to 9, 10, and so on and so forth. Okay? So we good? Okay, now. I want to replicate a learning curve like this that will be also dynamic. Note here that we will see that as far as the learning curve theory goes, it says that the higher the learning rate is, the less learning occurs per repetition. So remember that the learning rate is the complement of the learning that's going on. Okay? So when you have a learning rate of 99%, that means that there's really not much improvement, no matter how many times you perform that particular task. That would be what you will have. Not forever, but there's no improvement, but not much improvement. Okay? So this could mean one of two things. One, either the task, or actually three. One, either the task is very simple, there's not much to efficiency to be gained every time you repeat it. Two, if you're, let's say you're an HR director, and when somebody applies for a position, sometimes they give some kind of test, skills test, if you will.
Or personality test.
Yeah. You're given like 6 months to learn the job. You're on probation for 6 months. I think that's the idea. One of the ideas behind the probationary period is so that you can be observed and see if you really are good for the job. So let's say that you give an applicant some kind of test that measures learning ability. This person shows a 99% learning rate. What does that mean about that person?
You don't need to train them
Why?
because they're already optimized.
That's one. This person is already has already been trained.
I would
Two?
say that based off of the percentage, their ability to incorporate new information is high, so the amount of training time that you have to implement is low. So
The amount of what?
the amount of training time would be low, so that they have a higher function within that task.
Well, this one is that you already, there's no improvement, you will not expect improvement of this person
Yeah.
over time. So one, it's either the person is already good, efficient, or skilled at that particular task. That's on the one end. On the other end,
Task is just simple.
well, I already said that, that's the first one, task simple. The second is the person that's being tested is already skilled at that job. The third was the opposite end.
I guess like physical limitations. Like
Not limitation, but the ability to learn.
they can't learn.
They can learn. Okay? So of course, you can see if this person is already good at this job because you have the T1. How long did it take this person to complete the first unit? For this person, maybe this job is sort of the experience level, how many hours or how long it will take this person to complete the task. Then you can determine whether this person is expert or not able to learn. Okay? So as the learning percentage decrease, that tells you that the learning improvement is also faster. That's what I meant by the learning is the complement of the learning rate. But it's counterintuitive, isn't it? So when you hear the words, this job has a high learning curve, what does it usually, the common understanding?
Speed in which one has to learn. So
Speed, or is it
There's a lot.
easy or hard? Hard,
Yeah.
which is actually a compliment. If you say that this job has a steep learning curve, that means that it's a job that you can experience improvement rapidly. Okay? So maybe the next time you hear those words or that phrase, you might have a different understanding.
So you're saying that the high curve is a good thing, cause it means that people are learning a lot quicker?
The steeper learning curve.
Okay,
When we say, somebody might say, oh, this job has a high or a steep learning curve. That usually for
model
us,
learning tells me like.
It's hard.
I'm thinking it's like a complex system that you have
Yes.
to learn.
that's right. But actually, when you say that a job has a steep learning curve, that's what this means here. Steep, meaning there's a rapid learning.
Where would the credit go to for that? Would that
For
be
what?
the training program is, it's like a,
Well, it could be, no, it's just that because it's an ability, so it's, the credit will go to the person that you're testing,
hmm,
okay? Because every person will have different skills, abilities. So one person might have a 70% learning rate, one might have 75, just depending on how much we are able to learn from experience. So now, let's recreate this curve. Okay? Go back to the Excel. And then once we've developed this model, we'll go back and work the problems using the model we have developed. All right. I'm gonna move this up just one row, so I'll delete this. And I'll make it a little bit smaller so that I can fit in more rows. So our goal, or at least my goal here, is to recreate this curve. So it's an XY graph, your typical XY scatter graph, where you have on the vertical axis the time per unit, and the horizontal axis number of repetitions. So when you create graphs like this is an XY graph, you'll have to have two columns, a set of numbers. So here, I'm going to say this is n, number of repetition. And here, I'm going to create, say, unit completion time. I'll wrap that. So for the n, for the number of repetition, we'll start at 1 and then increment that by 1, 2, and then we can copy this sequence, so Excel will recognize that. Maybe I'll just create maybe 20 should be enough. If that's not enough, you can always copy the information that you have there. All right, the unit completion time. We will compute the unit completion time using, once again, the formula. All right. So the formula was, I'm just going to type it in here. Tn is equal to T1 times n raised to the power ln. These are characters, okay? So this is not really the function. ln r divided by ln2. Oops, the r converted
Into a trademark symbol?
trademark, yes. Okay, so that just, I wrote that there so you can see that that's the equation I will use in computing the unit completion time, right? So let's translate that now using the Excel function. Equals T1. Oh, let me show you something before I do that. It's a good practice in Excel that we use named cells or named ranges instead of using cell addresses. So if I put my cursor in C5, you'll see here the name box, it says C5. I can change that name to, I'll just say T1. I just typed it in. Okay. Oh, apparently it's already named. Oh, no, that's sorry. T1 is it's a reserved because it went to column T and 1. Say T underscore 1. There you go. So it didn't go to T1. And then this one, I'll use, let's see if learning percent would work. If not, you can just put a hyphen or a underscore. Yep, can do that either. So I'll use L underscore percent.
I think it's the percent sign. Doesn't like.
Does not like it.
I have to spell it out.
I just use the full word learning rate. And then this will just say, and hopefully that works. Okay, that did work. Okay, so let's see if those cells were named correctly. I'm going to press the F5 key, and the F5 key is a go-to key. So you see this, learning rate and T underscore one. I can go to that, okay, referring to that particular cell. All right. So the completion time for the first unit. T1, so I'm now using, instead of the cell address, I'm using the named cell. T1 times raised to the power, ln is a function, ln of learning rate, I spelled it fully. Well, as soon as I typed it, it recognized that learning rate divided by ln of 2. All right, so that is the unit completion time of the second or the first unit. Oops, no, sorry.
Change it to 1.
I was referring to 10, right, in my equation here.
Yeah.
This one, I shouldn't be referring to that. I should be referring to
The column next to it.
the cell C15. Okay, enter. Now, so that's the 50 we would expect to see for the first unit, which is that. Now, you might be thinking, why would I be using named cells instead of cell addresses, cell locations? Well, sometimes it's easier to edit or to proofread your equations or your functions if you're using terms or symbols that are representative of the equation. Okay, so then we'll just copy that down. Now, so let me make this bigger. So here are your two columns now, X and Y, that we will use in graphing. Highlight those two columns, we'll select insert, and we will select, we can probably just use a line chart. This, we didn't need that. If I included column C, I should have used the scatter chart, not this line chart. So there's your chart. If we change the percentage to a lower number, say 70, you'll have it much steeper curve. Yes, Jake?
No, I was just.
Okay, we're good? All right.
Can you click on the completion time for the first one?
I'm using that equation, the TN equation.
Oh, okay.
Okay? We're good? All right, now let me copy this. And in this equation, this portion of the equation actually tells us something about the learning rate applied to a particular nth unit. Okay, so we'll be in on this, the n raised to the power b. Okay, what is its interpretation? We go back to the Excel worksheet. So what I have here is if I remove this T1, so that my function will be left with this number, the n raised to the power b. Okay, this means something. we'll call this unit multiplier for now. If I copy this down, the unit multiplier tells us something about the efficiency that you have achieved at a certain number of repetition, okay? For example, if you're looking at the fifth unit, this 0.437 tells you that for the fifth unit, it will only take you 43.7% of the time of the first unit to complete. Conversely, in the fifth unit, you will have achieved a reduction or an improvement in time by about 56%. Does that make sense? You've reduced unit time by 56%. So that is the interpretation of the unit multiplier. If you ever see that in a model, that means something. Okay? Yes.
Is there ever a point where that, I guess the reduction is to almost,
Zero?
yeah,
Not really, it'll just keep on. In fact, it's probably at some point, this will not continue to go, but it might go up.
hmm,
It might go up at some point in time. Question is why, or what will cause that to go up? Economics. Diseconomies of scale. Right? Or the person's getting bored or saturated. Because of the task, it's just very repeated.
too easy.
Complex it is, at some point you will lose your
Productivity.
right? Okay? So there are things, something that is not considered here is there are criticisms to the learning curve theory. So this is not a 100% guarantee, but you have to understand also the limitations of models like this. And that's one of them. Okay. So it's a unit multiplier. Now, let me add another column here. So I'm going to insert, put that away. In column E, I am going to compute what is known as the cumulative, because in production, when you're doing manpower planning, or if you are costing a project, you're really not interested in the unit time per se, but rather you would want to determine the cumulative time. Let's say this project takes, I don't know, 10 repetitions. You would want to estimate the labor content or labor amount in building 10 items. So we can create here what we call as the cumulative time. And the cumulative time is simply computed easily by creating a running sum of column D. So we'll start with the first unit. We'll just copy T1. T2, the cumulative time for the second unit will be the sum of the cumulative time prior, or for the prior unit. And to that, we add the unit time of the current unit. Okay? So it makes sense. 50 plus 35 is 85. And since we now have an equation down here, we'll just copy that down. And this gives us the cumulative time for a given unit. Okay? So let's add one more piece of information here. You'll say cumulative time for T of N equal to 10. All right? But I don't want that to say to key in or type in 10. I want this to change to reflect this, right? So we'll edit this, we'll use the function concatenate again. See how I built it? I first type in the characters I want to see, and then I just edited the what I typed, and okay. So if I change this to 5. Now I'm going to create a function here. that will return, if I have n equal to 5, it will return 159.751. Okay, what will I do, or what function will I use? We will use the VLOOKUP function. So I typed in a function VLOOKUP. It'll identify the parameters that you need to input in that function. So the first input the VLOOKUP function looks for is known as the lookup value. What are you looking up for? I'm going to look up n, comma, and then it says table array. The table array in the VLOOKUP function, the lookup value must be on the first column of the table array. Okay, and in this case, that would be this n. And the table array, I'm going to highlight all three columns because I want to return the value in the cumulative time. Comma, it says column index. How many columns from the table value you want to return? And then we will say 3 there. And is called the number column 1. Unit time is column 2. The cumulative time is column 3. Comma. Do you want an approximate match? In this case, is our exact matches. So we'll just say 1 for true, 0 for false. So we'll just say exact match, right? And we can always test. If you make a mistake, I was telling Brian earlier, if you make an error, that's fine. We learn from it. So if this returns an error, then that means that I typed in the wrong logical value there. Okay, is that right? Okay. Let's change this to 10. Is that right? To 46. Now, what if you're looking at a big table and you have to search for the number over there? We don't want that. We want that to be automatic. That is, we want our model to highlight the column that has, or the row that has that number. For that, we will use conditional formatting. Okay? And we will create a new rule. Under the new rule, we will use a formula to determine which cells to format. Okay. So I want to format this cell, E15. The default in Excel is that E15 is fixed with a $sign. Let's remove that because I want to be able to copy the format of that cell all over the column. So in other words, I want that cell to change relatively. So I'm going to remove the $signs. I just have E15 equal to that C13. Now C13 it should be fixed because I want to be able to compare the cumulative time to that cell every time. And if this statement is true, we will format that cell, we will fill that cell. How about green?
Maybe a little bit lighter.
A little lighter, okay?
Read better.
Click OK. Now, once I click the OK here, nothing will happen to cell E14. Why? Well, 15 is not equal to 246.59. Click OK. All right, nothing happened. Well, now at this point, I can copy the format and paint that. And if I did it correctly, 246.589 will be green. Ah, like it now. And then, one more painter there. Oh, we check my conditional formatting. Oh, it did not capture this conditional formatting. Manage rules, it says there was no rule. Let's redo it. That equal to that format that. All right, there it is. Oh, I think I skipped this part, so I don't remember seeing this. Click OK. All right, now let's copy the format. This better work now. There you go. Okay, if I change this back to 5,
Then it highlights the.
That's right.
Section.
that's right. So in building models, you want as little intervention from the user as much as possible. When I say intervention, thinking, observing, looking for things. Good?
Is there gonna be instructions for this, posted somewhere so I can review it later?
It's recorded.
Oh, okay.
So that's the graph, and that's exactly the basis for how I created this model here. All right, just this one is this particular model computes the learning ratio. So to compute learning ratios, you need to have observations, the data from which to base or compute the learning ratio from. And the other is just a simple computing, the one that we just created. Okay, I just separated the unit completion time and cumulative time. The main formula that's used in this table is that one
Say
formula.
you created a template, right? from us?
That's how you build templates. You build it one layer at a time. All right. Oh, see this? T sub 1. There's T sub 1. You probably.
It's a regular one.
I want a I want to be subscripted or superscripted. You can do that. So if I want T1 to be subscripted, I will highlight one. You can see that over here. Right click on it, and then format cells, and then select subscript. Click OK, and there you go. See that?
Okay.
Subscripted. You can change the color. You can do all sorts of things. Another tip in building models like this, as much as possible, have as much white space. Okay, so then again, it's cleaner and easier to the eye. We good? Now that we have created that table, we can now answer the following questions or problems. If the learning rate is 90 and the first unit took 100 hours to complete, how long will it take to complete the 25th unit? For this, you can apply the formula and compute the completion time of the 5th unit. Since we built our model, we can just type in 100 there, 90%, and then 25, and there you go. 25th unit. Oh, I don't have the 25th unit. What happens here? And remember that I created the table when I used the VLOOKUP here. Where was my VLOOKUP? Oh, it's over here.
It should be the, yeah.
Yeah, there. When I create my VLOOKUP, look at my table range, C15 to E34. So if I want to edit the table and expand it, because like I'm only up to on the 34th row, I'm only up to 20. I want to insert more rows. So I'm just gonna highlight that. Be 10 rows is enough. Insert. Okay. And like I said, it's easy to just copy. And there you go. 25th unit, accumulative time is highlighted. But since I did not format this column, it did not highlight 61.3. Maybe we can copy the format here. Let's see if this works. Okay, remember that I formatted column E. So I'll click that paint format. Let's see if this works. It did not. So I'll have to go back and change the conditional formatting to include column D. So that's probably something you would want to practice, work on your own. So you learn how to do the conditional formatting. Okay, good with this? So how long will it take to complete the first 25 units from the table? You can use this table here if you want. 195%. This is, by the way, in your workbook, 90%. And I did not use conditional formatting here, so it does not highlight row 20 n equal to 25. Okay, next. How about this problem? An aircraft company is in order to refurbish interiors of 18 jet aircraft. The work has a learning curve percentage of 80. On the basis of experience with similar jobs, the industrial engineering department estimates that the first plane will require 300 hours to refurbish. We are to find how long it will take to complete the fifth plane, the first 5 planes, all 18 planes. Okay. What was the T1? $300?
300.
Okay.
80%.
80%. And so for question number 1, how long will it take to complete the 5th airplane? 178.69. I think the one we created is better, right? Because it has ability to highlight.
It has more inputs.
I'm sorry.
It has more changeability, right?
Yeah. The first 5 planes, that would be this. All 18 airplanes, that would be this. So if you were the project manager and you were trying to estimate the manpower that will be required to complete 18 jet aircraft to refurbish 18, that will be the basis for costing your labor, direct machine hours, overhead. So if you have cost per hour on all these, you should be able to generate an estimate of the cost. Now, if you were bidding on a project to refurbish 18 jet aircraft, then you have your cost, direct cost, overhead, materials, plus labor. You have your total cost, right? Is that the bid price? Remember, you're doing a competitive bidding.
You want to get your labor as accurate as you could.
Yeah, so let's say that this is the base for your labor. So the costing would include what? Labor, machine hours, overhead, that you charge on top of all the direct costs. So how important is it for us to estimate, have a good estimate of the labor? It's very important, right?
Yeah.
Because if you underestimate your labor hours, translation, you will put in lower labor cost. If you have lower labor cost, typically the labor hours are applied to machine hours. Okay, materials, that's easy because it's not based on labor, it's based on the 18 jet aircraft. But labor, machine hours, overhead. is a function of labor also. Sometimes, let's say, overhead is like 30% of total cost. So if you underestimate labor and machine hours, directly affected by that, your overhead is underestimated. Your total cost is underestimated. Therefore, your bid price will be lower, right? Yes, you will be competitive, but you might not generate profit. On the other hand, if you overestimate your labor component, your labor cost will be high. Your direct machine hours will be high. Your overhead will be high. Your total cost will be high. Your bid price will be high. You won't be competitive. Okay? So there lies the importance of understanding your labor cost component, especially in projects that are labor intensive. Okay? So we've done this. Problem 2. You are a contractor and you will bid on a job installing 30 in-ground swimming pools. And because this will be a new line of work for you, and you believe that there will be a learning effect for the job. After reviewing records from similar type of activity, you are convinced that an 85% curve is appropriate. You estimate that the first pool will take your crew 8 days to install. How many days should you budget for the first 10 pools? The second 10 pools? And the final 10 pools? Alright? How would you go about solving this problem using the templates? Let's just this one. T1 was 8. And it would be a good idea to write the unit crew days, not just days, crew days. Okay? I'll explain why. You probably know why we should be specific. The learning percentage, 85? Okay, so the first 10 pools, so I'm just gonna write it 1, 2, 10. Okay, don't want that to be. Okay. I'm gonna use this, so I'll type it in. So what's the first 10 pools? That would be first 10. That's the answer, right? Let's just round it up to 57 days. 57 crew days. Then 11 to 20. Or do we compute 11 to 20? This we can compute and say, how long will it take to complete the 20 pools? And from that, we will subtract. And we want to round this up. So you can use a function called round. And
Yeah.
oh no, yeah, let's round up. We added decimals. Crew days also. And then the final 10 pools, 21 to 30, would be round up 30 pools minus 20. Okay. Crew days. And once again, from a cost estimation standpoint, the 38 crew days will be your basis for computing your cost. Now, I stressed earlier, say crew days. You have to ask the question, what consists a crew? How many people? Say, hey, a crew consists of 5 workers. Next, you define what consists a day. Is it an 8-hour day?
10-hour day.
10-hour day? So you convert that five crew members times 8 hours per day, for example. Multiply that by 38. That will be your total person hours to complete the project. And that hours estimate will be the basis again for estimating your machine hours overhead costs. Okay? We good? And then finally, problem 3. Now, in the first 2 problems, we were given the learning percentage. But in situations where you are dealing with a new project or a new task, a new service, where there is no available historical data, even an estimate to base it on, you'll have to do your own sampling, do your own observation. And that's what I did, as I mentioned earlier, when in my class, estimating the completion time of assembling a Lego toy. All right, start. I want to copy. And for this, we'll just use the model computing learning ratio. Okay, let me paste the data that I copied. Now copy these and paste them here. And there you go. Okay. In most cases, 6 observations should be enough. But what happens if, because here you see the consistency in the improvement every doubling of repetition from 1 to 2, 2 to 4. Say that the numbers here are not that consistent, such that you need more observations. Again, large numbers, the more observations you have, the better your estimate becomes. What is the next highest number of observations that we need to obtain so that we can have our 4th observation?
8 and 16.
8, well, yeah, 8, first you'll have 8, 7, and then 8, so you'll have a number here. And then if 8 is not enough, what's the next highest number?
16.
Not 16. 5 is the next highest. I mean 10. Why 10? Well, 10 is doubling of 5.
Double.
Yeah, it's doubling. Does that make sense? And then if 10 is not enough, you'll have 12. 12 is a doubling of 6. Okay?
Wow.
So interval 2.
Yeah.
Okay.
But in most cases, 6 to 10 will be enough.
That only works because we had a recorded observation for 6, correct?
Correct, yeah. And with 6, we see a fairly consistent percentage there, so I'd say, hey, that's good enough. Right? So think about the consequences of not applying the learning curve appropriately and accurately. Talked about those 2.
Well, it seems that-
Overpricing, underpricing.
Well, it
yes.
seems the steps would be to find an example of data to use to locate good learning curve and then use that learning curve.
Well,
To
yeah.
estimate, forecast a certain projection.
So in a real life scenario, you've developed your learning curve based on like a current crew, right?
Mhm.
And then what happens if you replace part of the crew or like the whole crew? You need to redetermine your learning curve based on their training, right?
Well, it depends. If you're hiring a replacement, obviously you would want to replace a position with a person who has the same level of skill. If you don't, then your efficiency will suffer. So that's something that are you willing to bear that additional cost? Because if you have a crew, if you add a crew member that's not totally trained and it makes the crew less productive, that is a cost that you bear.
Mhm. And then if you're doing like a completely brand new project, you probably need a really low or
High,
learning curve, and then you bring it down as you scale your production. Is that kind of what the real world scenario would be?
no, if it's a totally brand new crew or a totally
Brand new like assembly line or something.
assembly line, or well, assembly line probably much, and like maybe mechanic, for example. A new engine kind of, that is, you'll have to, observe, adjust your price later on when you've observed several times, because at that point you'll probably have reached some level of efficiency.
Yeah.
So it's the cost associated with, well, when you hire a new employee,
Mhm.
that you invest in that person. So maybe you would think of that, the additional cost as an investment rather than a cost.
Mhm.
Hopefully that person will be trained and be more productive down the road. Any ideas where else we can apply the learning curve theory? Definitely in HR.
What about if you're
Okay.
creating a curriculum?
I'm sorry?
If you're creating a curriculum, like say a certification, and that's gonna be picked up for like a pilot program, right, but it hasn't been implemented in real world,
Okay.
how would you identify what the learning curve might be so that you could apply for a grant and identify the cost of that?
When you're talking about curriculum, you're talking about
Like an ISO,
9,000.
yeah,
That's usually a one time, that's more like a project rather than, because the learning curve theory is applied to something that you will do more often than just creating. When you create a curriculum, it's just a one time deal. Right? And I'm going to do that again.
what about like for a master standard, like a CSI construction, I think it's service or instructions, or yeah, CSI master standard.
What is that? I mean, I'm not familiar with.
So basically like the owner of the project will put out their own requirements, and then someone bidding on that project will look at the requirements,
Uh-huh.
and then they'll create their design based off of those requirements, and there's usually a master standard already associated
Okay.
with what those requirements are. That's called CSI. It's an international
Right.
standard.
So the question for you is that, is it something that you will do again? Or is it a one time?
Yeah, for example, I am creating a CSI master standard around ecological knowledge. I'm currently creating that. So it would be repeated every time someone goes to bid on a project and EKs and the owner requirements.
So in your case, you will be doing this multiple times or no?
Technically, I won't be doing it. I'm more so asking to identify what the learning curve would be for someone implementing it for the first time, since this is gonna be a new requirement.
And then for that person, is that gonna be,
They would
No.
then do it over again.
then that would apply, that, in that case, that would apply.
Okay,
So you can just observe how long it took for the first time, the second time, and so on and so forth. So the key here is that it is a complex process, and two is that you're going to repeat this complex process multiple times. And each time you carry out the process, that you or your crew are learning something, that you create efficiencies or you cut out non-value added activities or steps, because you're learning, you're understanding how to improve the process. So the repetition there is key,
okay.
okay? Without repetition, then this becomes just maybe just a one-time project,
Okay.
okay? It's applied to your academics also,
CSA, learning for students, learning curve models for students.
yeah?
Well, it can be applied to all kinds of different industries, so if you're a loan processor at a bank, the first
Yeah.
time that you process a loan will take you a lot longer than the
That's right,
200th time.
right.
When I worked at the Holiday Inn, the first time that I checked someone in, I was using the mouse to go to this field, enter the data, go to that field. Time I was a year in, it was all keyboard strokes and I could do it in a
Right.
minute and a half versus.
And you probably don't even have to look at the monitor, right? You can.
No.
It's a service industry, making
Yep,
foods and things like
Uh-huh.
that, cooking.
yep. All right, questions? Actually, the case associated with the learning curves is very interesting
For the- for the
Healthcare.
assignment.
for this, yep. And that we will apply things I talked about costing. We'll connect all those things. Okay? Students, on Zoom, any questions?
Nope, all
For
good.
me.
Thank
All
you.
good? All right, welcome, we'll see you next week. Next week is, I think, last topic, if I'm not mistaken. Cost volume analysis. So there's some connection between learning curve theory and cost volume analysis also. Okay? All right. See
Thank
you
you.
next week.
Thank
Bye.
you.
Thank you.
Bye.
Bye.